All right, so today we're going to be talking about different solubility rules that can impact how a solute dissolves into a solution. So here's some questions to think about as we're going through this lesson. True or false? All salts are soluble in water. True or false? All salts behave in the same way, meaning that every salt is the same as another salt. True or false? Salts are always sodium chloride. And true or false, salts are made of covalent compounds. So those are some things to think about while we're talking about the solubility rules of salts. So let's look at solubility rules and precipitation reactions. So these go hand in hand because they all rely on how something dissolves. So not all ionic compounds can dissolve. Some of them will actually not separate when they're put into water. Dissociation or separation occurs when an ionic compound separates into its ionic components. So if you watch my electrolyte video, I talk about dissociation based on strong, weak, and non-electrolytes. A strong electrolyte would be when an ionic compound completely separates. A weak electrolyte is when it kind of separates, and a non-electrolyte is when it never separates. Instead of doing experiments all the time to see which salts will dissolve, we use the solubility rules instead. So this is a list of rules that scientists have come up with over the years that describes how ionic compounds either dissolve or don't dissolve. So this kind of relates to how strong the bonds are in between those different ions. How much do they want to cling on to each other? These can predict the solubility of an ionic compound. So here are the solubility rules. Rule number 1 is that all nitrate salts are soluble. Nitrate is the NO3 group. It's a polyatomic ion. So anytime that you see a compound with NO3, it's going to be soluble. That NO3 is going to fall off. Rule number 2, salts containing the alkali metal ions, lithium, sodium, potassium, rubidium, and cesium, or the ammonium ion, NH4+, are also soluble. So if it contains something from column 1, or if it contains NH4, then it's going to be soluble. Ammonium is another polyatomic ion that will dissociate readily in solution. All right, so 1 and 2 relate to things that are soluble. Number 3, most chloride, bromide, and iodide salts are also soluble, but some of them are not. Okay, so not all chloride, bromide, and iodide salts are soluble. Exceptions include salts containing silver, lead 2, and mercury 2. So if it is silver chloride, it's not going to be soluble. If it is gold chloride, that's fine. If it is copper chloride, that's fine. If it's lead 2 chloride, that's not fine. Okay, so you have to be careful with these rules to look for exceptions to the rules. And there is a hierarchy, the higher the order on the list. So number 1 outranks number 2. Number 2 outranks number 3, which means that as we go on and we get to 4, 5, and 6, if there's a rule up here, like number 1, that it's going to supersede anything that comes below it. So this is like the hierarchy of them. All right, some more solubility rules. Rule number 4, most sulfate, SO4 salts, are also soluble. But there are some exceptions. So if you have barium sulfate, lead 2 sulfate, mercury 2 sulfate, or calcium sulfate, those are not going to be soluble. Okay, so where it says exceptions include, that means these don't follow the rule. Okay, so most sulfate salts are soluble, but these are not soluble. They are insoluble. Rule 5, most hydroxide or OH salts are slightly soluble. You can call them insoluble for our purposes. Exceptions include barium hydroxide, strontium hydroxide, and calcium hydroxide. In that case, these are pretty soluble. They're pretty okay. And rule 6, most sulfide, S, carbonate, CO3, chromate, CrO4, and phosphate, PO4 salts are insoluble. However, if you recall from the previous slide, if we have something higher up the list, like from rules 1, 2, or 3, and it contradicts something like in rule 6, then the first rule would apply. So for example, let's say that we have sodium sulfide, Na2S. Since sodium compounds are soluble, and since sodium was on a higher number, then it will supersede this. Okay, so sodium sulfide would be soluble because of the sodium. So let's practice, is it soluble or is it insoluble? Sodium nitrate. If you recall, rule number 1 says that all nitrates are going to be soluble. So it's soluble. We also know that salts containing sodium are soluble, so that's an added bonus. So it is soluble. Okay. What about iron 2 carbonate? So let's look at this one. Rule number 6 states that most carbonate salts are insoluble. There is nothing on any of the other 5 rules that mentions iron. So we're going to have to go with this is insoluble because it is a carbonate. When a solid doesn't dissolve, it is called insoluble. However, if you mix 2 different liquids together and you get a solid as a result of that mixing, that's called a precipitate. Okay, that means something is falling out of the solution. Okay, so the difference between insoluble and precipitate is that insoluble just means that it won't be dissolved. A precipitate is when you are mixing 2 things and the ionic reaction occurs and the resulting solute is insoluble. So precipitates form under special circumstances. So let's predict the products of the following reaction. If there's no solid precipitate, then there's no reaction. So here we have a reaction between lead nitrate and potassium iodide. Now recall, nitrates are always soluble. Iodides are usually soluble. With an ionic reaction, what we're going to do is we're going to switch the cations with each other. So we're going to switch lead and potassium here. So we're going to have lead iodide and potassium nitrate. Okay, so I just switched the cations to where they flip-flopped with each other. Now let's predict the solubility. So these little letters right here, this AQ and the S, those represent the state of matter that is present in the solution. AQ means it's dissolved in solution, it's aqueous. S means it's a solid. If you saw an L, that would mean a liquid, or a G would be a gas. So using our solubility rules, we know that nitrates are still always going to be soluble. So we're going to put an AQ there. Iodides are usually soluble. However, if you look at our different rules, iodide is not going to be soluble if you pair it up with lead. Okay, so that's an issue. If it's not going to dissolve, it's going to be insoluble. It's going to form a precipitate. So we're going to put an S by it because it's going to be a solid. It's not going to be soluble in solution. So that lead is what messes it up. Okay, and that's according to rule number 3, because lead is not soluble when paired with iodine. Okay, so if we're looking for the net ionic equation, what we're going to do is we're basically just going to write the balanced chemical and net ionic equations. So again, like on the previous slide, to determine what the products are going to be for this type of double replacement reaction, ionic compounds, we're just going to switch the cations. So the sodium is going to go over here, the calcium is going to go over here. So we get calcium carbonate and sodium chloride. Looking at the rules, chlorides are always going to be soluble. Sodiums are always going to be soluble. That's rules 2 and 3. Carbonates are generally insoluble according to rule 6. There is no special circumstance concerning calcium. Calcium's not listed anywhere else. So this is going to be insoluble. This is going to be our precipitate because it is a solid forming from 2 solutions. Okay, so that is my chemical equation. We would just need to balance it out, which we have already done here. When we're doing the net ionic equation, we just remove these spectator ions, the ones that are soluble. So the ones that can dissolve, we take those away. All right, so chlorine can dissolve, sodium can dissolve, we take those away. So we're left with the calcium and the carbonate over here. Again, sodium chlorine can dissolve, calcium carbonate cannot. So basically, we're just stripping it down to where we can see that the calcium and the carbonate are merging together to form an insoluble compound known as calcium carbonate. That's a little bit more advanced, but that's the gist of the net ionic equation, is just looking at which ions are forming the insoluble precipitate. So let's go back and think about those questions that we talked about at the beginning. So all salts are soluble in water. That is false. Not all salts are soluble according to those 6 solubility rules that we just went over. All salts behave in the same way. That is also false according to the solubility rules. Again, some dissolve better than others. Some don't dissolve at all. Salts are always sodium chloride. That is also false. The vast majority of ionic compounds are not sodium and chloride. And then finally, salts are made of covalent compounds. That is very, very false by definition. Salts are ionic compounds. They're made of 2 different ions. So, in review, let's go back to where we started. Okay, so let's review the rules. Nitrates are always soluble. Alkali metals and ammonium are always soluble. Chloride, bromide, and iodide are usually soluble unless you pair it with silver, lead, or mercury. Sulfates are soluble unless it's paired with barium, lead, mercury, or calcium. In general, lead and mercury just are not soluble. Most hydroxides are kind of soluble, but mostly just insoluble unless you put it with barium, strontium, or calcium. And finally, if you have a sulfide, carbonate, phosphate, any of those, or a chromate, then they're going to be generally insoluble unless there is a rule higher up the list than this one that supersedes it, such as if you put it with an alkali metal or with an ammonium ion. So keep these 6 rules in mind when you are trying to determine if a salt is going to be soluble or insoluble.